Right, so looking at enlargements and reductions, which usually refers to scale diagrams of some sort. And there's many types of scale diagrams. For example, a diagram, a model, or a map. These are all the scales. They're a smaller or larger depiction of some actual object or distance. And a scale is a ratio between, and the order matters. So a scale is always a ratio between the distance on the diagram or the model or the map, whatever that is, to the actual distance. So it's always in that order. The first number is always the distance on the diagram. The second number in the ratio is always the distance in real life. And scales are either showing enlargements, they're making something small larger, or reductions, making something big smaller. And so, for example, this is a scale. And by looking at what I have up here, I know by convention the first number, that must be the distance on the diagram. Oh, helps if I can spell. Let's try that again. Or a map or something. Okay? And the second number is always the actual distance. So to me, this looks like a scale appropriate for a map, where 1 centimeter on the map is 25 kilometers in real life. So for example, therefore, 2 centimeters on the map will be the same as 50 kilometers in real life. And if I had, I don't know, 2.5 centimeters on the diagram, on the map, then I want to go 25 times 2.5, which would be 62.5 kilometers. So all of these, the first value is on the diagram, the second is the actual distance. As well, what I can do to any ratio like this is I don't actually have to have units. And so one more thing I want to do before I look at a second one is if I can make the centimeters and kilometers the same unit, I can actually see the actual scale. What do I mean by that? Well, let's change that 25 kilometers into centimeters. So let's keep it as 1 centimeter, 2. First, if I change 25 kilometers into meters, I want to times by 1,000. We saw that in the last lesson. So if I go 25 times 1,000, I get 25,000. So that's now in meters. If I want to change meters into kilometers, I want to times by 100. So I can also write this as 1 centimeter, 2. 25,000 times 100 is an extra 2 zeros. So this actually, if I space this out properly, there we go. This is in centimeters now. Now, don't get me wrong. The first scale I gave you, 1 centimeter to 25 kilometers, I think is by far the easiest to work with. 1 centimeter on the map is 25 kilometers in real life. But if I change it to this form, I can now literally see that every 1 centimeter on the map is 2.5 million centimeters in real life, which means the map is 2.5 million times larger in any one direction than the actual distance, I'm sorry, is 2.5 million times larger than the distance on the map. And once you have the same units, you don't really need to write the centimeters. So in the end, I can also write this as just 1 to 2.5 million. So everything you see here is equivalent. I still like the first one the best. But there's lots and lots of ways of writing these ratios. And this is definitely an example of a reduction. How do I know it's a reduction? Well, first, just thinking about it, a map is smaller than real life. And so it's a reduction. Plus, I can also tell from right here. 1 to 2.5 million, any ratio like this I can write as a fraction. If I write it as a fraction, it looks like 1 over 2.5 million. I think of that as a fraction, 1 over 2.5 million. That is a number that is, much smaller than 1. And in general, anytime we have a value here, if we write it as a fraction that's less than 1, it's a reduction. But honestly, I feel like that's making it more complex than it has to be because it's a map. What you see on a map is smaller than what it is in real life, especially with this scale. Like 1 centimeter on the map is 25 kilometers in real life. This is the other way around. This is going to prove to be an enlargement. And so this means, again, 2 centimeters on the diagram is 1 millimeter in real life. And this could be like the schematics for some sort of electronics or something. Something that's small and we need to make larger. And so, for example, then I could say 1 centimeter on the diagram is 0.5 millimeter in real life. And there's lots of other ways I could look at it. Like before, though, I don't actually need to have these units. If I make both units the same, I'm going to make everything in terms of millimeters. So I'm going to change that 2 centimeters into millimeters. So 2 centimeters is the same as 20 millimeters. And like before, once I have the same units, I don't really need to write, oh, sorry, that should be 1 millimeter, not centimeter. Once I have the same units, I don't really need to write the units anymore. So I can now write this as just 20 to 1. So that's my scale without units, which literally means, according to this scale, everything on my diagram is 20 times longer than the actual distance in real life. And if I write this as a fraction, it's 20 over 1. And as I mentioned before, anytime you write, if you actually can get your scale to like a fraction like this, if the number is more than 1, it's an enlargement. If the number is less than 1, it's a reduction. But again, I can also just tell by looking at this that if 2 centimeters on the diagram is only 1 millimeter in real life, this diagram is definitely larger than the actual object. And so this must be an enlargement. And I will say the only other example is if it's not a reduction or an enlargement. That means the diagram is exactly the same in terms of as real life, and that's a 1-to-1 scale, and that's an actual size image. That's no longer a diagram. That's just like a recreation of something, or it's a life-size photograph of something. So unless it's actually an exact life-size recreation of something, it's either going to be a reduction or an enlargement. And again, maps in general are always reductions, and those are more common dealing with reductions. Usually, if you try to think about a scale diagram, it's something large that we've made smaller, like this. This is the tallest building in the world, at least at the time of me making this video. And the picture of it is smaller than the actual one. So I don't need to read anything else to know the answer to this first question. Is this picture showing an example of an enlargement or reduction? This is definitely a reduction. Okay, that's, that is not the actual size. Okay, that's smaller. So what is the scale then? Well, now I need to pay attention to this. It says the actual tower is about 830 meters tall. So it's 830 meters from here to here. Okay, so what's the scale of the image? Well, for me to find the scale of this picture, I need to, let me just make that a bit neater, I need to grab a ruler. And I need to see, okay, that's the 830 meters is in real life, or actual. But what's it in the diagram? So I grab a ruler. And I grab a ruler, and I need to measure from the same sort of distance, from the top to the bottom. On my diagram, this distance is about 11 centimeters. And so one scale, I could say, even though I want to clean it up a bit, again, the number that comes first in the ratio is always the diagram. The second number is always real life. So one thing I could say is that 11 centimeters is the same as 830 meters in real life. And that's one perfectly valid answer. 11 centimeters to 830 meters. That said, quite often it's nicer with a scale to have your first number be in terms of 1. So if I go from 11 centimeters to 1 centimeter, I can do that as long as I divide 830 by 11. And if I go 830 divided by 11, I get about 75.5. So I think that's a slightly easier scale to work with. 1 centimeter on this diagram, on this picture, is the same as, and I am rounding, is the same as about 75.5 meters in real life. Because now I can use that to measure other things. I can measure, for example, if I wanted to, I can measure the width of this building and get a good sense about how wide this building is, or how tall these buildings are, if they are, it depends on the perspective of them. That said, Another thing I can do is I can get rid of the actual units. If I change everything into centimeters or change everything to meters, I'm going to change everything into centimeters. So I'm going to leave that 1 centimeter. But if I want to change 75.5 meters into centimeters, I'm going to times by 100. And so I can go to a calculator, or I can just move the decimal 2 spots, and I get about 7,550 centimeters. And if I write it like this, I don't really need to have those units anymore. I can just say 1 to 7,550. These are all kind of equivalent to one another, which if I want, I can write as a fraction, as 1 over 7,550. And again, if you think about this number, 1 out of 7,550, that number is, that's definitely a number less than 1. So not surprisingly, this is a reduction, but I knew that just using common sense. But also this tells me that literally the actual tower is roughly 7,550 times taller than the picture you have in front of you. But of all these scales, I probably like this one the best. However, they're all equivalent. And again, if you have a scale with the same units, you don't actually have to write the units anymore. And that's what I have at the end here.